Hello friends, I am sure you must have seen the first and the second part of cardiovascular system. In the previous video of part 1, we have seen blood and the blood vessels, whereas in the second video, we have seen the anatomy and physiology of heart. Friends, today's video is very interesting. In this, we will see how heart does its function and the cardiovascular system. Friends, as you know, the function of heart is to pump the blood, and when the blood is pumped, it goes into the circulation. We have two types of circulation, that is pulmonary circulation and systemic circulation. These pulmonary and systemic we have seen in the previous video. Friends, this pumping of heart is due to the rhythmic contraction and expansion of the cardiac muscles. In this process, it has systole and diastole. In systole, it is the period of contraction, whereas in diastole, it is the period of relaxation. In the period of contraction, the cardiac muscle contracts, whereas in the period of relaxation, the cardiac muscle relaxes. When the cardiac muscle contracts, the blood is pumped out in the circulation, whereas when the cardiac muscle relaxes, blood comes in the chamber of the heart. This rhythmic contraction and relaxation of heart muscle is called heartbeat. Friends, we can also say that one apex systole and one apex diastole is called one heartbeat. Friends, this contraction and relaxation of heart muscle is controlled by a specialized group of nerve fibers. There are four types of a specialized group of nerve fibers present in the heart. These are SA node, that is sinoatrial node, AV node, that is atrioventricular node, bundle of His, and Purkinje fiber. Friends, these SA node and AV node is present in the right atrium. As you can see in this picture, these SA node are present on the wall of right atrium. These SA node, that is sinoauricular node, are also called as natural pacemaker of heart. These group of cells have ability to generate electrical impulse. The second node is AV node, that is atrioventricular node, which is present on the floor of right atrium. And whereas bundle of His is a continuation of AV node, but these are present in between the wall of right ventricle as well as left ventricles. And these bundle of His, they serve to transmit the electrical impulse from AV node to Purkinje fiber. And these Purkinje fibers are present on the subendocardial surface of ventricular wall. Now friends, we will see the conducting system of heart. Through this conducting system of heart, this heart is able to contract and relax. See friends, from SA node, there is a flow of electrical impulse. And from this flow of electrical impulse, these electrical flow of impulse is regulated through this autonomic nervous system. And these electrical impulse passes through entire atrium, causing contraction of cardiac muscle of atrium and forcing blood to move into the ventricles. At the same time, the impulse are also carried to AV node, which is present in the right atrium. Friends, there is a brief time delay as the impulse passes slowly through AV node, which allows time for ventricle to fill with the blood. These AV nodes carry the electrical impulse to the bundle of His present in the ventricle. From left and right bundle of His, these electrical impulse passes to Purkinje fiber. I mean, you have seen the Purkinje fiber which are present on the wall of ventricle. Now this blood bundle of His and Purkinje fiber spread the electrical impulse along with the ventricle, causing the contraction of these ventricles. And when this ventricle contracts, the blood passes into the from the right ventricle, it goes into the pulmonary artery, and from the left ventricle it goes into the aorta. So friends, after contraction, blood goes into the artery as well as the blood stream and from the different parts of the body. This contraction is called systole, in which we have seen that the blood passes out of the heart. In systole, the period of arterial contraction is 0.1 second and the ventricle contraction is 0.33 second, whereas in diastole the period of arterial relaxation is 0.2 second, whereas ventricle relaxation is 0.2 seconds. So friends, we have seen the total time in systole as well as diastole, that is one systole and diastole is 0.1 plus 0.33 second plus 0.2 second and plus 0.2 second. Total it is 0.83 seconds. This 0.83 second is the total time taken in one heartbeat. Friends, we have seen that 0.83 seconds we have one heartbeat. Therefore, in 60 seconds there is, that is in 1 minute we have 72 heartbeats, and the number of heartbeat in 1 minute is called heart rate. So friends, we have seen the heart rate, and in one systole there is a period of contraction in which we have seen the time taken is 0.43 second, in which blood is pumped out in the circulation, and in the period of relaxation, that is 0.4 second, blood comes in the chamber. Now here a question comes in the mind that what is the volume of blood which comes out in each systole? The total volume which comes out in systole, that is in one heartbeat, is 70 ml, and the volume of blood which comes out in one beat, that is in one heartbeat, which is 60 ml, is the stroke volume. So friends, we have seen that a stroke volume is the total volume of blood in one heartbeat. Now friends, we can easily calculate that how much blood comes out from heart in 1 minute. Friends, we have seen that in one heartbeat 70 ml of blood comes out, and the heart where also we have seen that in 1 minute we have 72 heartbeats. Therefore, in 1 minute we will get 5040 ml of blood which will come out from the heart in 1 minute. See friends, the total volume of blood which comes out from the heart in 1 minute is called cardiac output. Friends, we have seen that the stroke volume is the total volume of blood which comes out in one heartbeat, and the cardiac output is the total volume of blood which comes out from the heart in 1 minute. Friends, during systole the cardiac muscle contracts and blood goes out from the heart, and if you see the contraction in the picture, when the ventricle contracts, the blood goes from right ventricle to the pulmonary artery, and from left ventricle it goes into the aorta, and from pulmonary artery this blood goes into the lungs, whereas from aorta it goes to the different parts of the body. We have also seen that the volume of blood which comes out from the right ventricle as well as left ventricle in one heartbeat is 70 ml. So 70 ml of blood gives the lateral pressure on the wall of these blood vessels. So this lateral pressure of the blood on the wall of blood vessel is called blood pressure. Now friends, we will see the systolic blood pressure as well as diastolic blood pressure. Systolic blood pressure is the maximum pressure during ventricle systole, and the normal systolic blood pressure is 120 millimeter of mercury, whereas the minimum pressure during ventricle diastole is diastolic blood pressure, and the normal diastolic blood pressure is 80 mm of mercury. So friends, the normal blood pressure is 120 by 80 mm of mercury. That is the normal systolic as well as diastolic blood pressure. Now we will see the heart sounds. What type of sound which comes from the heart? Friends, there are two types of sound which is generally seen from the heart. One is lub. Lub is the first sound which comes due to closure of tricuspid and bicuspid valve, and the another sound is dub. The second sound comes due to closure of aortic and pulmonary valve. So these are the two sounds, lub and dub. They comes due to the closure of the valve. Now friends, we will see the cardiovascular diseases. When there is an abnormalities in the normal function of cardiovascular system, we have cardiovascular disease. In this, we see hypertension. Hypertension is the blood pressure above normal level. We see hypotension also. This hypotension is the blood pressure below the normal level. There is a atherosclerosis. This atherosclerosis is hardening and narrowing of inner layer of blood vessels due to deposition of cholesterol and leads to loss of elasticity of blood vessel. So blood vessels loses its elasticity, and this condition is called atherosclerosis. Heart attack is the sudden chest pain following interruption of blood supply in the coronary artery. In cardiovascular disease, we also see palpitation, which is irregular heartbeat. We have bradycardia, which is low rate of heartbeat than normal. Friends, we have seen that heartbeat, the normal heartbeat is 72 times per minute. And if it comes below 50, the condition is called bradycardia. And in tachycardia, there is increase in heart rate, increase in rate of heartbeat than normal. Cardiac arrhythmia is irregular heartbeat, and angina pectoris is compressive type of pain in the chest. It is the acute pain seen in angina pectoris. Friends, this infarction or myocardial infarction is also a cardiovascular disease. In this myocardial infarction, we have area of dead tissues produced by obstruction of arteries. This obstruction of arteries can be due to atherosclerosis or can be due to seen by thrombus formation. This thrombus is a clot fixed to the vessel wall by coagulation of blood. In all these conditions, we have cardiovascular diseases. So friends, we have seen the entire cardiovascular system. that is the organs which are involved like heart and blood vessels, and we have also seen about the blood which is also the main component of cardiovascular system. So from here we end this chapter. Now we will see the questions which are important in this chapter and which can be asked in the interview. Questions are: the name of organs of cardiovascular system, describe the anatomy of heart, what is the composition of blood, why the color of blood is red, distinguish between artery and vein, describe pulmonary and systemic circulation, name 5 cardiovascular disease, what are the function of WBC and RBC, what is blood pressure, what is systolic blood pressure as well as what is this diastolic blood pressure, what is stroke volume and cardiac output. And there can be many more questions, but these are the important questions which you can see from the videos. So friends, thank you very much for the patient listening. Thank you friends.